Okay, guys. So another question from Jimbo Slice there. It was 2016 question 10B. And basically, it's question is divided into two halves. It's a full, I say, a full half question on oxidation and reduction. The first part with the B part 1 and the B part 2 is to define um, uh, reduction in terms of electron transfer and in terms of oxidation number. So reduction in terms of electron transfer is reduction is gain of electrons, and in terms of oxidation number, reduction is a reduction in oxidation number. So that's the first part, 6 handy marks there. Then the remainder of the question is divided in two. There's a part worth 9 marks where you have to assign the oxidation numbers to an equation and decide which is the oxidizing agent and which is the reducing agent. So that's going to be the first half of the video. And then the second video that I'll do is where we balance the equation using oxidation numbers. But once you have assigned all the oxidation numbers to things and decided what has been oxidized and what's reduced, it's actually relatively straightforward. Okay, so you actually have half the work done for the second part of the question by just doing this bit here. So where's my pointer pen? There it is. So again, just to remind you guys that the rules for assigning oxidation numbers are on page 216 in your textbook. Okay, on page 216 in your textbook. So what I've done, guys, following the rules, I have assigned oxidation numbers to everything. Okay, and I'm looking to see which ones change. Okay, so as we know from yesterday, oxygen is -2. Okay, the chlorine is normally -1 except when it's bonded to oxygen or fluorine. So in this particular case, I had to find out the oxidation number of the chlorine. So if oxygen is -2, it has to add up to -1. I actually should do that one out there for you. So let's pretend I didn't know the oxidation number here. So it's x minus 2 is equal to -1. So x is equal to -1 plus 2. So x is equal to +1. And that's how I got the +1 there. Because if you remember, according to rule number 4, the sum of all of the oxidation numbers of all the atoms in a complex ion is equal to the charge. So that's a complex ion, that's a complex ion, that's a complex ion, that's a complex ion. Okay? So the oxidation number will add up to whatever that charge is. That's minus, so it's obviously -1. This one is 2 minus, so it's obviously -2. So that's what I had to do here. So as we know, oxygen is -2. There is 3 of them, so that's -6. So if I want to find the oxidation state of that sulfur there, there's 2 of them, so instead of it being 1x, it's actually 2x. So 2x plus -6 gives us -2. So 2x is +4. X is equal to +2. So we have found now that this has an oxidation state of +1. This is an oxidation state of +2. I should really put in the sign. Apologies there. Put in my sign. So this oxygen, this hydrogen, simple rules. Oxygen is -2. Hydrogen is +1. Now we go to this side of the equation and we have chlorine. It's actually kind of straightforward. The hydrogen here is plus, so it's obviously going to be +1. The chlorine is -1 up here, so its oxidation number is -1. The only one we really have to do any work with is here. So we have 1 sulfur and 4 oxygens. Now oxygen is -2, so there's 4 of them. So that's obviously going to be -8. So it's x plus 4 times -2 will give us -2. X is equal to -2 plus 8. So x is equal to +6. So the sulfur has an oxidation state there of +6. Now all we have to do, guys, is identify which 2 species have changed their oxidation number. So in this particular situation, it's chlorine and it is sulfur. So as we can see, chlorine has gone from +1 to -1. That means chlorine has been reduced. It has gained electrons, the oxidation number has gotten smaller. If something is reduced, that means it is the oxidizing agent. Okay? So chlorine went from +1 to -1. That means it had to have been reduced, which makes it the oxidizing agent. Now one thing I'm just going to stick in here, in order for chlorine to go from +1 to -1, it had to have gained 2 electrons. Okay, so it gained 2 electrons. Now that's important for the next step. I'm just putting it in now to show you. Right, sulfur has gone from +2 to +6, which means it has lost electrons. So it's been oxidized, which means that it's the reducing agent. So we've actually finished that first part of the question. We've gotten our 9 marks, but just to make our lives a little bit easier, the sulfur must have lost 4 electrons. Okay, so we've got the first part of the question finished. In the next video I'm going to do, guys, we're going to continue on and balance this equation. Now, they say we can balance either, but like with the bulk of the work done with this, it's, you know, the back of it broken, so it's probably better just to continue with this. Okay, it's probably better just to continue with this, and it's a good one to show how to do the full balancing question, because again, it comes up in question 10 a lot, and if you know how to do it, it's a handy 25 marks. And again, you just have to follow a different set of rules, but we've actually got the back of it broken here. Okay, so I'm going to stop this video, and then I'm going to move on to the second half within a couple of minutes. Okay, bye bye.